Okay. Guys, a couple things before we get started. The handout that you just picked up, we're going to do that. That's extra review for us to do tomorrow. Today, we're going to finish up on, in our packets, the log test review. We did page 26, and we'll do the other 3 pages today. Couple things. Tomorrow, device returns. Okay, so if you have a Fulton County issued device, make sure you bring that tomorrow along with your charger, and we'll go as a class. For those of you who do need to returns, go down and we will go through the line and hopefully be able to get that done quickly. And then we'll come back here to do more review. I know there are those of you who want to take the test early tomorrow, so if you want to do that. My first through 3rd period is open. My AP Calculus students are done. There's still some students who are in there doing makeup work or trying to do recovery, but it's basically a pretty quiet environment, 1st and 3rd. So if you have any openings that you can take the test, 1st through even 1st and 4th, or 6th period, basically anytime outside of class, you can take it. So if you really want to take it tomorrow and just get it over with, you can do that. But the test is scheduled for Thursday. And then if you're not here tomorrow, Thursday, then you'll take it Friday. But that should be the last grade that will go in the grade book. Also, on the test, you will get to use your calculator, but you'll need to show all your work to justify all your answers. Okay, so if I just see an answer with no work, I'm not going to give any credit, even if it's correct. Okay, so I need to see supporting work to earn credit. Okay. Any questions about today through tomorrow or Thursday? Okay. So we finished 26. Is that right? Do we finish all the way through 26? Thanks. Okay.
I did.
What do you need? Yesterday. So, are you doing class tomorrow?
I'm not sure.
Are you taking this? All right, so let's go to page 27. All right, so 16, we are condensing using trying to get everything down to one log term. So usually when we condense, we always take care of the coefficient first. So we go through power property first, get all the coefficients up. And then once all the coefficients are up as exponents, then we can do a combination of product and quotient property to merge all those separate terms into one log term. Okay, so go ahead and try that, and I'll reveal step-by-step work after you guys have a chance to try each step. So we make all the coefficients go up as exponents. Just be careful with that last term. When you bring that 1/3 up, we can't just say 7c to the 1/3 because that 1/3 is going to affect both the 7 and the c. So to ensure that the 1/3 sees both the 7 and the c, we put the parentheses around the 7c. All right, so now we want to use product and quotient property. A quick way to know where those values go, we're trying to figure out where do we put the a, the b, and the 7c. And you look to see whether the term is part of a positive or negative log expression. If it's positive, you're going to leave it up in the numerator. If it's negative, you leave it in the denominator. Now, when you put it into one condensed expression, your parentheses is not going to contain any plus or minus between terms. Everything is either being multiplied or divided. So the denominator, you can leave it as 7c to the 1/3, or you can do cube root of 7c. Either is fine. That question was 16. Okay, 17. Okay, so this is quotient property. So the question is there anything else that we can do with what's inside the parentheses to clean those parts even more? We could, but I don't think that's going to allow for things to clean up, right? We can't cancel across addition or subtraction. So we're not going to FOIL this out. But what about the denominator here? Or we can factor, right? Factor. So x squared minus 1 is difference of squares. We can factor that as what? X plus 1, x minus 1, right? And if I have x plus 1, x minus 1, what do you notice here? The squared means what? How many? Yeah, I got 2x plus 1s, right? So if I write it out, x plus 1, I can see common factors that I can cancel out, reduce. Right, we can't cancel across addition and subtraction, but if we have parentheses that matches, then we can take those out. So the x plus 1s can reduce, and we're left with just log of x plus 1 over x minus 1.
Wait, so how did the x plus 1s reduce if you can't cancel out?
So the x squared minus 1, right, x squared minus 1 is the difference of squares here. X and x. Factors to the x plus 1. X plus 1 squared, what does this mean? X plus 1 squared means I have 2 x plus 1s, right? So I have an x plus 1 and x plus 1.
Oh, you just can't cancel out if it's plus minus. So you have to keep the x plus 1 and x minus 1.
That's right. I can't do this. All right, 18. Power property first. All right, bring all the coefficients up. So we need to find a place for the x to the 5/2, the y plus 8, the y cubed, and 10 minus x. And just purely depending on whether it's part of a positive or negative natural log, then we know whether to put it in the numerator or denominator. All right, so the next part, solve right answers in simplest form. We always want to see if we can get the bases to quickly match, because if the bases can easily match, then we can just remove the bases and set the exponents equal. But if the bases are not easily matched, or it's not easy to match the bases algebraically, then our next option is to have to take a log of both sides and bring the exponent down and solve for x that way. So if you look at 13 and 14, they look to be ones where we can kind of imagine the bases working out nicely for us. So what's a base that we can match for number 13? Yeah, 9 is fine, or you can bring it down to 3. I think I may have used 3, but 9 you would get, yeah, maybe a little faster with 9, you'll get the same answer. So if you did 9, you would just change the right side. You'll make the right side 9 to the second power, and then set 3x plus 1 equal to 2. I went all the way down to 3. We'll still get the same answer either way. If you're dealing with exponential functions, meaning that there are no logs to begin with, there's no need to check for any extraneous solution, right? Whatever you get for your answer, that's your answer. Okay, what about 14? What's a common base that we can choose? 5. Yeah. Try that. Once the bases match, you can just remove the bases and just worry about the exponents and solve for x. Okay, 15. How would you start 15?
add 13.
Yeah, add 13, okay. So 13 plus 5 is 18, okay? Then what would you do? Divide by 4, right? We want to, we see an exponential function, but we want to try to get that down to the simplest form that we can get, right? So if there's any things that we can do, whether it's adding, subtracting, or combining like terms, we want to take care of all those things first, and then we can worry about dealing with the next step. So I get 18 divided by 4, which is 18 over 4, reduced to 4.5. So I'm left with e to the 2x equals 4.5. I want to solve for x. X is stuck in the exponent. It doesn't look like we can get the bases to match easily like 13 or 14. So what can we do to take care of that variable exponent? Take what?
Take log.
Yeah.
Okay, logs.
Yeah, so log will work, okay? If you take log of both sides, that's perfectly fine. It's just that if I see e involved, I like natural log. It's just there's one less step to worry about. And natural log and e have a way of just canceling out cleanly. But it's not wrong if you took log of both sides. It's just you have just have an additional step at the end. You'll still get the same answer. So I like this natural log b to 2x. The 2x can drop down in front because of power property. Natural log of e becomes 1. And now I just have to worry about solving for x divided by 2. Now I want to make a distinction here. This 2 and 4.5 are not compatible, meaning that this 4.5 is inside the log, but the 2 is outside. So if you write your answer like this, this is incorrect. Right? The 2 is in the denominator of the entire natural log of 4.5. It's not just in the denominator of the natural log. So make sure, it doesn't seem like a big deal, but these mean different things. There's questions there. All right, 16. Nothing to add, subtract, or divide. That's as clean as it's going to get. Is it easy to find a common base there for 16? Now, we can't quite get that 12 in terms of base 2 or base 4, so we're kind of stuck in with those bases. So what can we do? What can we do to eventually get that solve for that x in the exponent? Yeah, take common log, right? Take log of both sides. That will allow the x minus 1 to now freely move. And once that x comes down, x minus 1 comes down, then you have a lot more algebraic options to get to your answer. Either divide log 4 over and add 1, or you can distribute the x through and solve for x. Here's another option what they can do with 16. Same thing. Okay, either way works. Okay, any questions up to 16? Okay, 17, e to the 2x minus 3 to the x equals 10. We can't combine. Those are not like terms. We can't say 2x minus x. The bases aren't matching. Well, sorry, the 3 is getting in the way. So we really have to think of this as factoring. Think of this as e squared, and this is e to the first power. So why don't we just let x equal e to the x and pretend like we're working a easier factoring problem. Factor that trinomial, and then we can bring the e to the x back, and then we can go through solving. So multiplies to be -10, adds it to be -3, -5 and 2. But this isn't the problem that we're actually solving. We're just able to solve or do an easier factoring problem, but then now we want to bring back the original variable, which is e to the x. Now we can set those parentheses separately equal to 0, and then involve natural log to bring the x down and solve for x. Okay, the e to the x minus 5 is going to be fine. We're going to be able to work our way down to x equals natural log 5, but the other factor, e to the x plus 2 equals 0. If I try to bring that 2 to the other side, it becomes -2. If I take the natural log of both sides, the right side is going to give me some issue, right? We can't take the log or natural log of a negative number. It doesn't exist, so we have to remove that and call that the solution. '18 is going to have a similar feel to 17. Trinomial factoring with easier variables, and then we can bring the e to the x back to the problem. So instead of the original equation, I'm going to just think of it as 3x to the 4th minus 5x squared minus 2 equals 0. Factor that instead. Multiplies to be -6, adds it to be -5. Once you're in factored form, bring the original variables back, and then you can try to get the e to the x by itself. Take the natural log of both sides and see how far we can go to get x by itself. Okay, questions with 17 or 18? Okay, number 19, the bases are not going to be able to be matched. We're going to have to take the natural log of both sides, but number 19 is going to feel a little bit longer than the previous problems like 15 or 16, because I have exponent variables on both sides. So when I take the natural log of both sides, we're going to have two sets of variables on either side of the equation that we have to worry about. So it's just going to make the problem a little bit longer to try to get x by itself. So log of both sides. Bring the exponents down. Now the exponents are multiple terms, so as the exponents come down, protect that term, expression with a set of parentheses. So you can remind yourself, I gotta distribute that log 4 to both sets of parentheses. Or sorry, log 4 and log 11 to both, to their respective sets of parentheses. Distribute log 4 through the left set of parentheses. Distribute the log 11 through the right side of the equation. So it looks like a mess, but really you're just trying to solve for x. So let's group the terms that have x's on the left. Let's put the terms that have no x's on the right. Factor the x and divide over. So your answer will look messy, but you'll get full credit because that's what I want to see. I want to see the work. I don't really care if your answer is cleaned up, as long as you can show me the work and show me what x equals to. That's what I'm looking for. So even though you have a calculator, I don't really need to see decimal answers. Okay, you can leave your answer unsimplified. So if you do all this without a calculator, just some students were asking about it, so I wanted to give you guys a way to check. Okay, I'll leave it on this page for a minute or two. I know that there's a lot of writing here. Right, but page 28, whenever you're ready. So all this page is solving exponential equations, getting from exponent into log form to solve for x. But the next page, we're starting with log expression, and sometimes we may have to convert to exponential form to get some clarity as to what our answer is going to be. Does anybody still need this page? Yeah, that's fine.
So when you, so at step 2 of 19, and then you distributed and then you got all those, why did you have to get what was on each side? Like, why did you have to subtract and add the log 11? It gets to the other side.
Let's see. Are you asking how I got from the first step to the second step, or why we?
How'd you get from the third step to the first step?
Oh, here to here.
Yeah.
Okay, because I want to solve for x. So because I want to solve for x, I find the terms that have x's in them, and I move it so that I can get my x's together.
Yeah.
And then I can factor the x out. And I can move the rest of it. Okay, are we going to page? Sure. Okay, so go to page 28 and try number 20. So the first thing you do is coefficients up. Okay. And then the next decision you have to make is, where do I put this a to the fifth, e to the sixth, 7c? You know it's going to be log base 4. It's going to have to be either above or below. So I look at the log term and I say, okay, is this positive or negative? This part is positive, so this positive is going to live. It's See, this is log term, this is part of a positive log term, that's going to count as well. This is part of a negative log term, so I think that's part of a negative log term.
And, oh, B squared is,
Yeah, and I let you leave it like this, or I can make a cube root.
and, that would be the power of those.
This, well, the power property is bringing the exponents up. The product property is putting things in the numerator. The quotient property is putting things in the numerator.
Okay. Also, there is, so why would power property not that disappear?
Yeah, because natural log e is the same thing as log base e, right? That's what natural log. If I have log base e of e, that's just going to help cancel each other out.
Okay, thank you.
Okay, page 28. All right, so now I'm starting with a log equation. I want to solve for x, but x is stuck inside the log form, and I can't really separate that x away from that log expression. So we can go to a different form. So how do I convert from log form to exponential form? Start with the what? Base 8, right? 8 to the second power equals 3x plus 1, right? So once you get into exponential form, then everything feels a lot easier, because then it just looks like it's like an equation that you're used to solving, right? Subtract 1, divide by 3, and you have x. The only thing you have to be careful about with log equations is when you get your answer, you still have to check for extraneous solutions. So what that means is you're going to take your solution, you're going to insert into the parentheses of the original problem and see if it causes any parentheses to be a negative. If the x value causes the parentheses to be a negative value, then we got to remove it and call it extraneous solution. So 21, if I insert 21 in for x, there's no issue. 21 times 3 is a positive, plus 1 is positive. So if it doesn't cause the original parentheses to, or argument to be a negative, then we can keep it. Negative or 0, sorry. Negative or 0 are ones that we have to remove as extraneous. Okay, questions with 20? Okay, 21. I want to solve for x, but let's see if we can do some cleanup. What can we do first? Subtract 5, okay. Natural log of 3x equals 0. 3x is stuck inside log form. I'd like to get that natural log to show me of something a bit more helpful. So natural log is a shorthand, hand form of writing what? Log base e. Okay, so if I get that log base e to show up, it becomes a little bit easier to see what the base is and converting to exponential form. All right, so how do I convert that to exponential form? E to the 0 equals 3x, yeah. And anything to the 0 power is 1. Okay. We still have to check for extraneous solution. 1/3 in for x is not going to cause any issues. 3 times 1/3 is 1, so the parentheses is not going to become negative, so we're good. Okay, 22. I have multiple log terms. I don't want to convert to the exponential form just yet. I would like to merge the two log terms together. So what can I use to merge these two terms together? Product property, yep. So once I apply product property, so I can multiply the x and x plus 6. Distribute the x through, and now that we have a log term, a single log term equation, we can convert to an exponential form like the previous problem. Okay, so what would the exponential form look like? 4 to the second equals. Good. So if you look, if you do that, you have 3 terms here. You got a variable to the second. You have a quadratic. You have a linear, and you have a constant. We're gonna have to factor. We got to bring everything over to one side, set equal to 0, and go through trinomial factoring. Okay, multiplies to be negative 16, adds it to be 6. A to negative 2. Solve for x. So we need to test our solutions with every argument that we see. So I know I said a set of parentheses, but there's no parentheses here, but there's an understood parentheses here. If the negative a causes even one of these to be a negative or 0, we have to remove it. Okay, so if it passes 2 of the 3, but then it fails if it fails any one, then we have to remove it. Okay, so even if it works for some of them, it needs to work for all of it in order for us to keep them. Okay, now 23 and 24, we see natural logs on both sides, so we're now thinking, okay, if I can set both two sides of the equation to both show natural log, then I can just remove it cleanly and then just focus on the arguments. But before I can do that with 23, what should I move to make it natural log equals natural log? Yeah, let's move that 2 to the exponent. So now that the 2 comes up, it becomes a lot cleaner. We can remove the natural log and just focus on the argument. Okay, so there's 2 ways of doing this. You could take the square root of both sides, but it's a little messy keeping track of all the plus or minus. So what I did was I FOILed out the right side, brought everything over to the left side, and I went through factoring and solved for x that way. And I also checked for extraneous solutions, but both of these did not cause us any issues with the parentheses. Negative 4/3 is safe with both parentheses.
I think 4/3 works out. Oh, you plug it in, right?
Right, we plug in, right? So it's not a standalone negative. A negative could be okay as long as it doesn't cause the parentheses to go to negative, right? Okay, any questions with 23? Okay, 24, if you're looking at 24 thinking, okay, I see log base 7 on both sides, I would like to remove it. That is what we want to do eventually, but not yet, okay? We can't do that if there's multiple logs added or subtracted. We got to find a way to condense and get it log 7 equals log 7, but that's not quite the case yet. So what can we do to make that happen on the left side? Quotient property again. Now you can remove log base 7 and just focus on the parentheses. I would remove the log base 7s. I would set it up as fraction equals a fraction, and I can make that right side x plus 1 over 1, and I can cross multiply, and maybe I have to go through factoring again, but at least I get my denominators out of the way.
Why couldn't you subtract, log 7 on to the other side and put it as the,
You could, yeah, you mean you wanted to add, well, I guess what you could do is you could move this over and then go through product property and set x plus 6 equal to 2x times x plus 1. Is that what you were thinking, or?
yeah, like set like the equation to 0.
Oh, okay. Yeah, you could do that. You could do that, set everything equal to 0, make it quotient and product property and set equal to 0 and cross multiply that way.
Okay.
That works too. So if you get, we should all arrive at the same answer. If we're not getting to the right answer, then even though the other method is fine, maybe something didn't quite work out. So let me know if you're going through a different method and not getting the same answer as me. So -2 is an issue, not because it's negative, but because it causes one of these to go to a negative, right? Okay, page 29. Let's go to graphing. All right, does anybody still need page 28? Sorry. I'll go back. Okay, so page 29. Graph the parent function. State the asymptote, domain, and range. So we like to go through our characteristics. First, focus your attention on the argument. So where's my vertical asymptote? 0. We know log 1 is 0. So log 1 is 0. What can I choose to get the basis to match? 4. Log base 4 of 4 is equal to 1. And what can I do to get the basis to be the reciprocal? 1/4. And 1/4 will give me negative. Okay, plot that graph. Yes. And then we can list out the fill out the characteristics, right? Domain is from 0 to infinity. Range is all real numbers. Asymptote is x equals 0, and x-intercept we see right here, 1, 0.
I'm still kind of thinking of how, like, how did you know where to put it?
Mm-hmm. So basically, I'm going to always set the parentheses equal to 0 to find my vertical asymptote. So my parentheses is just the x. So when I set x equal to 0, that's my vertical asymptote. And my second property is I want my parentheses to be 1. If I can get my parentheses to be equal to 1, then I know log of 1 is 0. So there's nothing that's influencing with the x. So I can just pick 1, and I know log of 1 is 0. And next is if I can get the parentheses to be the same value as my base, then I can get this property to show up. I know log base of b is equal to 1. So I want to force that parentheses to be 4. But when I force it to be 4, I know log base 4 is equal to 1.
Thank you.
All right, 26. All right, let's list out the transformations here. It could be a reflection, it could be a stretch, compression, could be left-right movement, could be a shift up or down. There are two things that are changing about the parent graphs. What are those two things? Left 6 and down 2. Yeah. All right, so 3 big characteristics here: vertical asymptote and 2 order pairs. So how can I get to the vertical asymptote? Set what? Yep. And what's my argument? X plus 6. Yep, my parentheses. Okay. So -6. All right. What can I do to take advantage of the second property? Say it again.
-5.
-5. Okay, so let's see what happens there. Okay, I want my parentheses to show me a value of 1. So if I force x to be -5, -5 plus 6 is 1. And that's going to force this whole thing to be log of 1, and log of 1 is equal to what? 0. And then 0 minus 2 is -2. That's how we find. Okay, so what can I do to make my parentheses match the same value as my base? -2, right? So if I choose -2, -2 plus 6 is 4, and that's what I want. I want base 4 and my argument to be 4. So if I choose -2 for x, -2 plus 6 is 4. Log base 4 of 4 is equal to, yep, and 1 minus 2 is -1. Okay, if there's any shift left or right, I don't think it's worth it to go through this. It's just more trouble than it's worth. But this is enough to get a good look at the graph, good picture of the graph. And there's one more thing that I want us to look for, and that's the x-intercept, because it's not showing up here, right? So how can I find the x-intercept? Set equation equals 0, yeah. Set equal to 0. Now I'm just solving a log equation, right? Add 2 to both sides, convert to exponential form. Base 4 raised to the second power equals x plus 6. 4 squared is 16. Solve for x is 10. So my x-intercept is 10, 0. Okay, try 27 and 28. See if you can list out order pairs, list out transformations, sketch the graph, find the x-intercept, identify characteristics. And then in a few minutes, I'll show the answers and I'll come around and I'll check these 4 pages. Or yeah, 27 to 30. Okay, everybody okay with page 29? Okay, everybody okay with 27? Okay, let me check your 4 pages, page 27 to 30.
So you can just plug in one into it next. And the rules of law. One is zero. Yeah. And then if it's one over. That last roll. Yeah. No, it's just.
I'm doing it back to you.
Okay, bye, good night.
There's something behind your ear.
You'll be like,
Have a good day, Mr. Yang.
Okay, good day. You want to brag?
No, just take my pencil.
yeah.
Well, how about this? Yeah, I don't think I can do that. However, I have to see more review worksheets.
Okay.
So tomorrow, you come in, I'm gonna do that review worksheet, and take that as a test, and then you can grade yourself out of it.
Okay,
How's
thank
that?
you, yeah. Thank you.
I can see it, see it.
I got like last test we did review this weekend.
I haven't.
Cause like, oh, I got like a bad grade on that, like a 70 something. And I wanted to see it, like, and I thought it was pretty well.
Sure.
I'm just like laughing.
I thought margin of error was, the distance of the area like between those.
Margin of error is this portion.
Oh. Okay. Alright, that was a little confusing. Alright, well.
I mean, yeah, recovery is not worth it.
Thank you. Is there gonna be like no more grades after this test?
This is the last.
Okay.
See you.
Have a nice day.
Have a nice day.